Hey everybody, I'm going to do this last example. Apparently my old video, the audio cut out. So this table shows a meteorologist's predicted temperature for an October day in Sacramento, California. What is the quadratic model? In other words, go ahead and get like a equation, and our calculator will do that for us in standard form. And then we're going to use that model to predict the high. Hopefully you know the high. Another word for high is maximum. And from previous studies, that tells us that we're going to need to find the vertex. Let's take a look at our information. We're going to change all of these hours. Instead of being like AM versus PM, they're all just going to be hours after midnight, okay? So like 8 AM is 8, 10 AM is 10, 12 PM is 12. Now here's where it gets kind of weird. It's like military time. 2 PM, instead of being 2 PM, that's 14 hours after midnight. 4 PM is 16 hours after midnight. And 6 PM is 18 hours after midnight. So the points that I'm going to put into the calculator are these X values and these Y values. I have a TI-84 calculator pulled up here on the left. And I'm going to input those into, get rid of all these adds. Input those into my L1 and my L2. So stat and edit, type them in, 8, 10, 12, 14, 16, 18. And you should be doing this with me as well, whether you have a handheld device or you're using the same website I am. Temperature goes up, so it's 52, 64, 72, 78, 81, and then that temperature is going to head back down, 76. I'm double checking all my numbers because I don't want to redo anything. The next buttons I need to hit are stat. I'll go over to calc, and we are looking at quadratic regression. That's our x squared, L1 and L2, and my equation is over there. So I'm going to fill this in now, okay? So we have y equals, I'll use 4 significant digits. Negative 0.4, actually I'm just going to use them all. No, I'll use 4. 4688 if I round properly. Minus 14, oh, that says positive, sorry, so plus 14. 7, 2, 1472, x, plus negative 36.12. And please remember that y is the predicted temperature, and x are the hours after midnight. So what is the high? Well, we have learned that to find the vertex, we do opposite b over 2a, and that's going to give us our x value or our h value. That's okay. And then we're going to put those in. So negative 14.72, if you want to use more decimals, it is more accurate, times 2 times my a value. And we're going to type that in. I like to type that in my calculator as follows. I would do 2 times negative 0.4688 and then negative 14.72 divided by that answer. All right, so my x value is 15.70. Now remember, this is hours after midnight. So to get the temperature, I need to plug that in. So I'm going to grab, now this is my maximum temperature. Okay, so every time I see an X, I'm going to put in that number. All right, so negative 0.4688 times 15.70 squared plus 14.72 times 15.70 minus 36.12, and this should give me my maximum temperature. And then again, this is just a predicted value, would be 79.43 degrees Fahrenheit. Now, if you're wondering why that doesn't really match our chart, is because this model, while it's a great model, it's used as an estimate. Now, how do I know that doesn't match my chart perfectly? Because I can see that it gets to 81. All right, so it's important for you to recognize that this quadratic model is simply that. It's just a model of the best they can do. So we're going to say using our model, we see that it happens, what is that as a time? Can we do that? That's like almost 4 p.m. Okay, almost 4 p.m. And that matches our data on the table. And the predicted maximum temperature is 79.43. So reasons this is off is because our points don't make a perfect parabola, and we did a lot of rounding. But you get the idea that you have to make your model using your calculator, and then to find the max or the min, you do your vertex by doing opposite B over 2A. And that's all I have for you.